Hello everyone. Now we will implement naive Bayes algorithm in colab. Naive Bayes algorithm in colab. I am going to open a new file in colab. A new file. So for loan dataset, I am taking loan dataset, whether loan is paid or not, what are the conditions, all those. So naive Bayes, this is the classifier. This is the classifier. Bayes algorithm, Bayes theorem it will be using. How the Bayes theorem will work. And we have to calculate prior probability, likelihood probability, Bayes formula we have to apply. This is a general example, sunny day, rainy day, overcast, all that. And then I am going with loan data. Actually, I am going to implement with loan data using the new Bayes algorithm. You can see these are the columns in the loan data: credit policy, purpose, int rate, installment, log, annual increment, DTI, days with all this. What is the due date, not fully paid the loan. All these are the columns available inside the loan data. I have opened a new notebook in the Colab. I am going to import the loan data. I am going to import the loan data. Browse option should come. Then we will import the file inside the Colab. Now using this browsing option, loan underscore data. So this is the CSV file. I am going to import the CSV file inside Colab. On the left side it should come. Once it is imported, on the left side it should come. Now I will import the libraries required. I am importing the libraries required. NumPy is for arrays and matrices. Pandas is for data structures and operations on numerical values. Cbond, Matplotlib, they are for plotting purpose. Next, I am reading the loan data inside the coding, Python coding. And you can right click the loan file on left side, right click, copy path, and you can paste it here. The same I have already done. This path will come, execute. Now it has come into the Python coding, the data inside the file. I am going to display first 5 rows in the loan data. Head means first 5 rows. Tail means last 5 rows will be displayed. You can see what are the columns available inside the loan data. First 5 rows are displayed. Okay, all the columns are available. Next, what about the information? Info means information present. We are assigning it to df variable. The loan data we are assigning to df variable. What are present inside the df variable? It will mention clearly. Info is the function which will tell what are the values present inside the dataset file. One of the column is purpose. Other column is not fully paid. We are taking these two columns and making the count plot. We are taking only these two columns and making the count plot. SNS is also used for, you can see here, count plot is done. Credit card, major purchase, educational, not fully paid is taken as the hue, output variable. Next, I am going with how many dummies are present. Get the dummies and drop them. After that, display the first 5 rows. We are getting the dummies, then drop them first. After that, display the first 5 rows. So it will remove all the unwanted or less valuable information from the columns, and after that it is displaying the first 5 rows. Next, we are using the train test split. We are importing this function from the sklearn library. we are dropping, uh, we are taking the not fully paid. So X and Y, we are dividing the entire data set into X array, Y array. Then we are applying 66% for training, 33% for testing. 66.66 for training, 33% for testing. And then we will get the values into X train, Y train, X test, Y test. Next, we are making the model using Gaussian naive Bayes algorithm. Gaussian naive Bayes, we are importing Gaussian naive Bayes from the sklearn library, and then we are making the model. Fit means making the model. We are giving the X train, Y train training data, 66.67 percentage data we are giving. Now we are doing the prediction using 33% test data. We are doing the prediction by using 33% test data, and the prediction value is available in y underscore predict. Now we can plot the confusion matrix. We are assigning the confusion matrix. Y test, Y predict we are taking. Y test, Y predict. And we are assigning it to CM variable. This will have the confusion matrix now. We are taking Y test, Y predict. Then assigning the confusion matrix to variable CM. Now we are going to plot the confusion matrix. We are going to plot the confusion matrix. So you can see here CM is the variable used, heat map is the function, SNS is the variable for Seaborn library, CM is the variable we are assigning, X label, X ticks fully paid, not fully paid, Y ticks, Y label also fully paid, not fully paid will come. Now this CM will have the confusion matrix, and you can see this is again 2 by 2 matrix. This is true negative, true positive, false negative, false positive. Now we will use the formula to display the true negative, true positive, false negative, false positive values from the 2 by 2 matrix. So the values will be displayed. These are the 4 values: true positive, true negative, false positive, false negative. Now we have formulas for accuracy, precision, recall, F1 score. Using those formulas, we are getting the metrics for naive Bayes algorithm. Next, we will have true positive rate, true negative rate, false positive rate, false negative rate. We have formulas for that. So we are going to get those metrics also. We are applying the formula, then displaying the final values for the naive Bayes model, naive Bayes algorithm. So with this, we have got the output in naive Bayes algorithm on diabetes dataset. Loan dataset. Loan dataset, and we have applied naive Bayes algorithm. Naive Bayes means probability calculation. Then only it will apply the algorithm. Bayes theorem is applied. Thank you.